Hello everybody and welcome back to Calculus 1 at Frederick Community College with Professor Val Lockman. In this video I will talk to you about the product rule for computing derivatives, and I will go through several examples showing how to apply this rule. So let's just jump right into it. We have the following rule. It says that if I want to compute the derivative of a product of two functions, then it's computed this way. It's f prime times g plus f times g prime. So it's important to see that it's not f prime times g prime. Okay, that's one of the common mistakes that students tend to make at the very beginning of the course. Okay, whenever you compute the derivative of a product of two things or more, it is not just the product of their derivatives. So let's go ahead and go through several examples, and once you have enough practice, you will see that it's not so bad. Okay, first example says the following. Compute the derivative of a function f of t is 2t squared times 4t minus 1. Let's go ahead and apply our rule. So you can think about it as this is your function f, this is your function g, right? Well, actually I already have f, so let's make it h. Okay, so these are two different functions. I'm going to compute my derivative. So f prime of t is the derivative of the first times the second unchanged plus 2t squared times the derivative of the second. Okay, that's the setup, right? So for the first few examples, I would strongly encourage you to write it out like that, all the details. And now we compute derivatives. This is 4t times 4t minus 1 plus 2t squared, and the derivative of 4t minus 1, that's just 4. Okay, now we'll multiply it through, combine like terms. So we get 16t squared minus 4t plus 8t squared. Okay, and this is equal to what? 24t squared minus 4t. Okay, that is your derivative. Let's go ahead and compute it a slightly different way. Okay, what if I were to distribute the function first? Okay, so let's go ahead and distribute first. So this would be f of t is equal to 2 times 4, that's 8t cubed minus 2t squared. Okay, we know how to compute the derivative of this. Okay, let's see, 8 times 3, that's 24. 3 minus 1, that's 2, so the power gets reduced by 1. Minus what? 2 times 2 is 4t. Okay, and notice that they are the same function. 24t squared minus 4t. That is your derivative of this first function. Okay, now you might be saying, well, isn't it easier to distribute it first and then compute the derivative? In this case, absolutely. Okay, but the point of this example is just to show you how to apply the rule. Okay, when it comes to solving problems, you do them any way you want, whichever one you prefer. Okay, let's go ahead and take a look at the next example. All right, example 2. I'm going to apply the quotient rule first, and then I'm going to distribute it and see if I compute derivatives two different ways and I get the same answer. Okay? All right, let's do this one. So f prime of x would be, I'm going to write out all the details first. Prime of the first times the second plus the first function times the derivative of the second, right? Okay, let's see. The derivative of 1 is 0. the derivative of 1 over x squared, remember this is x to the negative second power, right? So this would be negative 2x to the negative third, okay? This term doesn't change, plus 1 over x squared. The derivative of x squared plus 1 is 2x, okay? Let me rewrite this one right here like this, negative 2 over x cubed times x squared plus 1. And this one I'm going to multiply through. So this would give us 2x. And then 2x times 1 over x squared, we can reduce by x. So we're going to get plus 2 over x. Okay, let's see. I'm multiplying through here. I'm going to get negative 2 over x minus 2 over x cubed plus 2x plus 2 over x. Some things will cancel out. The final answer, I should get 2x minus 2 over x cubed. Okay, so notice what I've done. I did the setup first, right? So first prime times second plus first times second prime. That's just following the formula. Then I carefully took the derivatives of each of the functions, multiplied through, combined like terms. Let's go ahead and do this problem by distributing first, just like the one above. Okay, distribute first. Again, in practice, you do whichever way is more convenient for you. So f of x would be what? Let's see. 1 times x squared, that's x squared. 1 times 1, that's 1. Plus 1 over x squared times x squared, that's another 1. And plus 1 over x squared. So the function is x squared plus 2 plus 1 over x squared. We can find the derivative of this. Okay, let's see. The derivative of x squared, that's 2x. The derivative of 2 is 0. And then the derivative of 1 over x squared, that would be negative 2x to the negative third, right? Which is the same as we've gotten before. You notice this and this derivatives are the same. Okay? All right, let's go ahead and do another example where we have e involved. Okay, this one. Okay, what is my function? It's e to the power of y times y cubed plus 2y. Okay, f prime of y is going to be e to the y prime times y cubed plus 2y plus e to the y times y cubed plus 2y prime. At some point, once you develop these skills of finding derivatives relatively quickly, you can skip this step, but I strongly encourage you to do this step at the very beginning. So e to the y prime, that's just e to the y, times y cubed plus 2y. Okay, what happens here? E to the y stays, and then the derivative here would be 3y squared plus 2. Okay, you can leave it like that, or if you want, you can factor out e to the y, and then inside you're going to get a polynomial, right? So y cubed plus 2y plus 3y squared plus 2. Okay, so either one of these answers will be fine. All right, let's go ahead and take a look at another example where we have a product, and now we have a trinomial involved here. Okay, so the first term has 3 terms. Okay, how do we deal with it? Same way as before. Nothing changes here. Okay, let's see. F prime of z. The derivative of the first times the second function unchanged plus first function times the derivative of the second, right? Prime. Okay, the derivative of the first one is 3z squared plus 8z plus 1. Z minus 1, that doesn't change. Okay, plus what? This function doesn't change. The derivative of z minus 1, that's just 1. All right, now we need to multiply everything through combined like terms. All right, so what do we get here? This is 3z cubed plus 8z squared plus z minus 3z squared minus 8z minus 1. And here we just drop the parentheses. Okay, let's combine our like terms. Let's see, cubic term, that's 4z cubed. Quadratic, let's see if this is done. Okay, what's quadratic? 8, negative 3, and 4. And what is this? What does it give us? 9, right? So plus 9z squared. Okay, linear term. Okay, that gives us negative 6. And the constant is negative 1. Okay, let's take a look. 4z cubed plus 9z squared minus 6z minus 1. Okay, so if you really want, you can FOIL this first, then compute the derivative and see if you get the same thing. You should get the same thing, right? In mathematics, if we do the same thing with two different methods, two correct different methods, we should get the same answer. Okay? All right, let's do one more problem for the product rule. Okay, let's take a look at this one. This one says the following. I have 4 times e to the t minus 2t times t squared plus 4t. Okay? The product rule will still apply here, but one of the common mistakes here would be saying, okay, well, the derivative of 4 is 0, which is right. 4 prime is 0. So the whole thing is 0, okay? But that is not true. Remember, the derivative of a product is not the product of the derivatives, okay? So what you're going to do here, you're going to factor 4 out. Okay, remember this rule right here. F prime, actually let me see, so f, let's say we have c of f of x prime, right? We can pull out the c and then find the derivative. Okay, we know this rule from previous lectures. Okay, so that's what we're going to do here. We're going to say, okay, what is our f prime of t? It's going to be 4 big parentheses here, and now I'm going to compute my derivative using the product rule. So that's e to the t minus 2t prime times t squared plus square root of t plus, I'm going to move them here, plus what? E to the t minus 2t times the derivative of the second. Okay, so look how that 4 is outside and is going to distribute through the whole thing. Okay, that's one of the common mistakes, that you either forget about it or make it 0, so the whole thing is 0. Yeah, we want to avoid that. Okay, so now what? This is 4 times what? E to the t minus 2t prime. What is that? E to the t minus 2 times t squared plus square root of t. Okay? Plus what happens here? This function stays as is. What is the derivative of t squared plus square root of t? That would be 2t. And remember what this is. This is t to the 1/2, right? So if I were to find the derivative of this, d dt, what would that be? 1/2 comes down. T to the power 1/2 minus 1, so that's negative 1/2. Okay? So we're going to get plus 1/2 t to negative 1/2. Now this, of course, could be simplified. But for my class, you can keep it as is. Okay, this is fine. So the main point here is, one of the main points is not to lose that 4. Okay, make sure it distributes through the whole thing. And then carefully computing these derivatives one at a time. Okay, so common mistakes to avoid. Okay, let me write it down. Mistakes to avoid when computing your derivatives using the product rule. Okay, first of all, f times g prime, this is one of the most common mistakes, is not equal to f prime times g prime. Okay, make sure you actually use the product rule. Second, okay, if you have a constant c, okay, then just pull it out, okay, factor it. Okay, so remember this rule, c f of x prime, that's just c times f prime of x. Pull it out, then distribute through the whole thing. Okay, and also one other thing that can happen, drop in parentheses. Okay, what do I mean by that? So let's say over here, if you drop the parentheses, then you say e to the t minus 2 times this other quantity. You're distributing only -2 through that product, right? But you actually have to do the whole thing. So that's one other thing that can happen. Make sure you don't drop these parentheses if you have more than one term in your derivative. So definitely keep track of all the parentheses. That's one of the mistakes that happens all the time. And then, you go back and you try to figure out what happened. Everything looks right except the parentheses are not there. All right. Okay, I hope you found this helpful. Thank you for watching.